Hey everyone, welcome to hok'stutoring with term 3 well and truly on the way. That only means that you'll be doing static and dynamics very soon. In today's topic video, I will be going through inclined planes, which is one of the topics of statics and dynamics. There are 4 main scenarios in regard to inclined planes, which I will use as the structure of this video. There will be external force and no external force, and then I will segment each of them into smooth and rough inclined planes. Now, before I get into the 4 scenarios, there's 2 assumptions that need to be known. 1. Friction will always be in the direction that opposes the motion. So if the object is going up the inclined plane, friction will be going down and vice versa. 2. The external force that I use here in this video will only be parallel to the inclined plane. Alright, now that those are out of the way, let's get into it. Scenario number 1. Smooth inclined plane with no external force. The forces affecting the object on any inclined plane includes the weight force, which goes directly down, and the reaction force, which is always perpendicular to the surface. Naturally, if an object is placed on an incline, it will slide down, so there must be some kind of force pulling it down, and that force is the horizontal force parallel to the inclined plane, which is caused by the weight force. We draw this invisible triangle with angle equals to theta, which is also the same angle as that of the incline. Using trigonometry, the horizontal force that we're interested in should equal to mg sine theta. Of course, we also have the vertical force here, which once again using trigonometry should equal to mg cos theta. The reaction force has the same magnitude in order to keep the object from flying up or going straight through the ground. To find acceleration, we use Newton's second law of motion, F equals ma, with the resultant force being the horizontal force going down the inclined plane, as that's the only force moving the object. The reaction and the perpendicular force cancels each other out, so you really don't have to consider that. Scenario number 2. Rough inclined plane with no external force. Similar to the first scenario, the forces affecting the object includes the weight force, bringing along with it the horizontal and vertical forces as well as the reaction force. However, since the object is on a rough inclined plane, there exists friction, which will always oppose the motion of the object. Naturally, the object will slide down the inclined plane, meaning that friction will be in the other direction, so that means going up. Newton's second law of motion formula will thus be horizontal force minus friction equals to ma. If you want to know how to calculate friction, I'll be having a video coming out soon, so make sure you keep a lookout on that. Scenario number 3. Smooth inclined plane with external force. In this scenario, there is an external force pulling the object upwards. This means that the forces affecting this object's motion will be the external force and the horizontal force component of the weight force. The object will move in the direction of the force with the larger magnitude. If the external force is larger, then the equation will be set up as the external force minus the parallel force, and vice versa if external force is lower. And to the toughest of them all, scenario number 4, rough inclined plane with external force. Just like the previous scenario, the 2 main forces affecting the object's motion are the external force and the horizontal component of the weight force. As I've said before, the object will move towards the direction of the larger force. However, in this case, due to the rough inclined plane, we need to also take into account friction. If the object moves down, friction will go up, and we set up our equation accordingly. And if the object moves up, friction will go down instead. And that's about it for the topic video, guys. If you want to check out some actual problems regarding this, I've made tutorial videos which you should definitely have a watch. I really hope this was useful towards your studies. If you enjoyed the animation, please leave a like, I would really appreciate it. Aside from that, guys, thanks for watching, and I'll see you next time.